Some problems from section 3.2 having to do with solving systems of linear equations using substitution. So first we'll look at problem 1 on page 134, which says that we have the system y is equal to x minus 5 and x plus y equals 9. So this is our system. We're solving by substitution, which means we want to isolate one variable in the equation, in one equation. So isolate a variable in one equation so that we can substitute into the other equation. So looking nicely, right here we see that we have an equation or a variable that's already isolated. So simply, I can, since this is isolated, we're going to substitute the information here into this equation wherever we see y. So we have x plus, instead of y, we're going to substitute in what we know for y, which is x minus 5. And then keep the rest of the equation as is, equals 9. We combine our like terms, so x plus x is 2x, the minus 5 stays, is equal to 9. We still need to get x, now we need to isolate x, so we add 5. Because what we're trying to do is right now, and this, when we're given this, we have two variables, and we can only solve for one variable at a time. So by substitution, we're able to get our equation down for one variable so we can find it. So we find that 2x is equal to 14, and we find that x is equal to 7 when we divide both sides. So we know x, but we need to know y. So I'm just going to select equation. So I'm going to say x plus y is equal to 9. I could have picked the first one. There was no reason I selected this one. I'm going to substitute in. We know that x is equal to 7. Say 7 plus y is equal to 9. We have our equation with one variable, y, we're trying to solve for. Subtract 7 from both sides. Y is equal to 2. So what we have here, x is equal to 7, y is equal to 2, is we have an ordered pair 2, 7. This is what we call our solution to our system. If we were to graph both of these equations, we'll see that this is where they intersect. So if you want to pull out your graphing calculator and graph both of these, remember that we need to get this one to look like y equals. So it would be y is equal to 9 minus x. Okay, put this equation and this equation into your calculator, you'll see that they both intersect at the point 2, 7. Try another one. This is number 3. 3x minus 5y. Oop. I'm copying the wrong problem. Sorry. I was doing number 5. All right, so question 3. 2x minus 3y is equal to negative 1, and x equals 4y plus 7. So again, we want to try to isolate one variable. So we look at this problem. 2 is not isolated. We've got everything else here. We look at this equation, we find that x is isolated. So we don't always have to isolate x, it just works out this way and for these two problems that we've done. So I'm going to use 4y plus 7 and substitute it in anytime I see x in the first equation. So 2 times 4y plus 7. Okay. So this 4y plus 7 just get interchanged with that x. I'm going to continue with the rest of the problem. Minus 3y is equal to negative 1. Distribute. 2 times 4y is 8y. 2 times 7 is 14. Minus 3y is equal to -1. Combine our like terms. If we have 8y and we take 3y away, we're left with 5y. Plus 14 stays, and we have -1. We need to subtract 14 from both sides. 5y is equal to -15, where we find that y is equal to -3. Now that we know what y is, we need to go back and find out what x is, so we have the ordered pair. So we're going to take this and substitute it back into any equation. I'm just going to randomly pick the first one. 2x minus 3y equals -1. 2x minus 3, we know that y is equal to -3, and that is equal to -1. We perform our simplification, right? Combine like terms. We have 2x minus 3 times -3, means this is plus 9, is equal to -1. We need to subtract 9 from both sides. 2x is equal to -10. X is equal to -5. Combine these together and we find that we have a solution. One solution to this system of equations is -5, -3. This is where the two lines will intersect. And remember, a solution to system equations where we have one solution is where the lines intersect. So trying another one that may not look as pretty, but is still very doable. Let's take a look at number 21. Number 21 is 2x plus y equals 2, and we have 5x minus 2y is equal to -13. Just making sure I copied it correctly. 2x plus y equals 2. 5x minus 2y equals -13. So again, we're using substitution, but what we notice is that right now we don't have a variable isolated. So looking through this, I want to find the variable with a coefficient of 1. And that's just going to mean that I have less work to do to get it isolated. So as I look at our equations, x in the first equation has a coefficient of 2, but y has a coefficient of 1. So let's isolate this y. So to show you what I'm doing, I'm pulling this equation out. 2x plus y equals 2. We want y by itself. So I'm going to take 2x away from this side and 2x away from this side. So we are left with y is equal to -2x plus 2. That's one equation. And our second equation remains unchanged. 5x minus 2y equals -13. So now we can very easily use substitution, substituting this equation in for y. So 5x minus 2 times y, which is -2x plus 2, equal to -13, comes from here. Distribute. -2 times -2x is a positive 4x. -2 times 2 is a -4, is equal to -13. Combine like terms, 5x plus 4x is 9x, minus 4 is equal to -13. Add 4 to both sides. 9x is equal to -13 plus 4 is 9, so x is equal to -1. So a little bit longer because we had to shift some variables around, but still doable. We're not done yet though, because we need to find out what y is. So I'm just going to select an equation. I'm going to select the first one because y is already by itself. 2x plus y is equal to 2. And I'm going to substitute my value in for x that we just solved for. So 2 times negative 1 plus y equals 2. 2 times negative 1 is negative 2 plus y is equal to 2. I need to get rid of this negative 2, so I'm going to add 2 to both sides, and we find that y is equal to 4. Therefore, our solution to this system is negative 1, 4. So these are the points where they intersect. We could have some additional not so pretty problems, and that's just if we involve fractions. So I'm going to look at question 39, which is 2/3 x plus 1/2 y is equal to 1/6. And we have 1/2 x plus 5/4 y is equal to 11/4. So the first thing that we notice is that we have fractions. So we want to clear our fractions by multiplying by our lowest common denominator. So the lowest common denominator of 3, 2, and 6 is 6. So if I take 6 times 2/3 x plus 6 times 1/2 y is equal to 6 times 1/6. 3 and 6 have a common factor of 3. 6 and 2 have a common factor of 3. And 6 and 6 have a common factor of 6. So we can rewrite this as 2 times 2x plus 3 times 1y is equal to 1. We're going to do similar to our other equation. Here we have a denominator of 2, 4, and 4. So our lowest common denominator is 4. 4 times 1/2 x plus 5/4. I forgot to multiply. Plus 4 times 5/4 y is equal to 4 times 11/4. So 4 and 2 have a common factor of 2. 4 and 4 have a common factor of 4. And 4 and 4 have a common factor of 4. So we are left with no ink or lead. So we are left with, for our second equation, 2x plus 5y is equal to 11. We can simplify this first equation. 4x plus 3y is equal to 1. All right, so now we've done a lot of work already, but these equations are much more usable and user-friendly than the fractions. So we need to isolate a variable. Up to you what variable you'd like to isolate. Again, these aren't the only ways of doing this. Right? I'm going to say let's isolate this x. So we have 2x plus 5y is equal to 11. I have to take the 5y away from both sides. So we have 2x is equal to negative 5y plus 11, and divide both sides by 2. So x is equal to negative 5/2 y plus 11/2. So I know it still looks like we've got fractions, but it's all right, right? We're going to substitute those into our first equation up here. 4x plus 3y equals 11. So we have 4. Our x is equal to this, negative 5 halves y plus 11 halves plus 3y is equal to 1. Distribute. 4 times negative 5 is negative 20 over 2y plus 44 over 2 plus 3y is equal to 1. We can still clean this up a little bit. Negative 20 divided by 2 is negative 10y plus 44 divided by 2 is 22 plus 3y is equal to 1. Negative 10y plus 3y is negative 7y plus 22 equals 1 minus 7. I need to get rid of my 22. Subtract 22 from both sides. We have negative 7y is equal to negative 21. Y is equal to 3. So, unfortunately, we are not yet done, but we're told that y is equal to 3. That's what we found out. So we can pick one of our equations and substitute back in. So I'm going to pick this equation here. Again, for no real reason, just picking it. 2x plus 5 times 3 is equal to 11. 2x plus 15 is equal to 11. Subtract 15 from both sides. 2x is equal to negative 4. X equals negative 2. So the solution to this is negative 2, 3. And that's our solution to our system of two equations. So it definitely is more work when we have fractions. This is just one way to do it. We could have worked with the fractions the entire time, but I know students typically have an aversion to fractions. So this is just another option for you. sweetie. I paused it.
Huh?
I paused my video.
Okay.
Did you know him?
No. Nope. I don't know why.
You don't have to know why, sweetie. It's okay. You want me to get your face back?
Yeah. Yeah, they're all